In this lesson, we're going to talk about angles a lot and the measure of those angles. But before we get going on angle measures, we need to be able to figure out what actually makes up an angle. Now, we're going to start with a ray. Now, we've talked about lines already, and we've talked about segments already. A ray is similar to both of them. A ray now, as you see, it's going to be part of a line, just like a segment was. But here you have it starting at point A and continuing on through B and C. So we call this ray AB or ray AC, and I'm going to get to that. Similarly with the green ray, it would be called ray XY or ray XZ. Now, we want to be able to write down what we're talking about. We want to be able to label our rays. So in this case, when we get to the first one, the orange one, we could call that ray AB. And then, similar to what we did with segments and lines, we're going to put a little symbol above it, and we're going to make the little ray symbol. Like I said earlier, we could also call it ray AC, just like that. Now notice, both ways I named my ray, I started with the end point. Anytime you're going to talk about a ray, you have to start with the end point. If you come over and you look at the green one, now that's going to be called ray XY. And I know the actual ray looks like it's pointing kind of to the left, but when you look at the symbol that you put on top of your ray, you're going to use the arrow and it's always going to point to the right. We could also call it ray XZ, like that. Now sometimes people will think, well, I can just pick any 2 points and you're going to call it ray YZ. Now ray YZ exists up there, but ray YZ is only this much. That's ray YZ. So if you want the whole thing, everything that's green up there, you have to make sure you use one of these ways to describe it. This one is just what I have in the blue up there. Now you get to opposite rays. Hopefully this is a little self-explanatory. Opposite, pointing in different directions. So now you're going to have 2 rays put together that are pointing in opposite directions. Key part to this is they have to have a common endpoint, and then extend in those opposite directions. So my examples here, I have ray BA. Well, when I come up here, here's ray BA, and then I have ray BC. Notice together, I like to think of it, they're making a line, but the 2 rays share that common endpoint at B. Now if you go to my next example of ray BA, same one again, so I guess I'll just circle that in red again. But then you talk about ray AB this time. Now notice you have this common ground in here where they're sharing everything in here. So because they share more than just an endpoint, those are not opposite rays. Now the angle. I'm going to go on a limb and say most of you have a pretty good idea of what an angle is going to be. By definition, it's going to be 2 non-collinear, and I'm not real big on this non-collinear part. I know the book has that, but I'm going to leave that off, and I'll show you why in the next slide. So think of an angle as just 2 rays that have a common endpoint. And then I have a picture here. You have the interior part of an angle. I like to think of it, in most cases, it's the smaller part, the interior, and then you have the exterior. That I like to think of, it's the bigger part. So interior and exterior, and then you also have on the angle. On the angle would be everything that you see here in the brown. The sides of the angles, well, those are just, those are the 2 rays. So here's one side, which is a ray, here's the other side, which is a ray, and then that common endpoint is referred to as the vertex. So that's the basic pieces of an angle. Now again, we want to be able to talk about it. It's like our segments, like our lines, our points, everything we've been able to name. Now there's multiple ways to name an angle. There's the 3-letter approach, which is the longest one, and we're going to start off with angle. That's the angle symbol, and we can call this angle ACB. Notice C is in the middle. That's the vertex, and it always has to be there. We could also call it angle BCA. Not a whole lot different, just changing the order, but make sure that the vertex is always the middle letter. Now, when there's no confusion, we can go with the shortcut approach, and we can just call this angle C. Base it off whatever the vertex is. And I'll get into an example and show you what it means when I talk about if there's no confusion. And then the last way is sometimes there'll be just a little number in here. Maybe they'll put a 3 inside of this angle, and then we can refer to it as angle 3. The little numbers inside, that's a great way when there's a bunch of angles in a picture and it's kind of confusing on what's what. It's just a fast way to reference them. We can call it angle 3. Protractors, I'm going to get one of those out and show you how to measure these. So with your protractor, put that on my screen. Bring that up maybe. I thought I would. There we go. Just a little slow, I guess. To measure an angle, oh, I guess there's already one up here. A little technical difficulty. Give me a So we want to measure our angle. Take your protractor. Make sure that the pointed part, which would be right here, I call that the point of the protractor, is on your vertex. And then line up one side of your protractor with one of the sides of the angle. Now when I look at this, the 0 of the protractor is right here, which means I'm going to follow the inside numbers around on my protractor until I get out to here. And I'm noticing that the measure of my angle is approximately 134 degrees, maybe 135, somewhere between 134 and 135 degrees. So when I come down here, I'm going to say that to show this, I'm going to say the measure of angle, and I could use any one of my angle ways to name it, angle ACB equals 134 degrees. Now you could measure it the other way as well. You could take your protractor and line up the other side. Now notice the zeros on the outside, and you'd follow that outside number around, and you're going to get to that same spot of 134, 135 degrees, somewhere in there, give or take. Now the ways to classify angles, we have 4 different ways: acute, right, obtuse, and straight. So our acute angle, think of it as it's a small one, and it's going to be somewhere between 0 degrees and 90 degrees. Now the measure of the angle cannot be 0, and it cannot be 90. It has to be somewhere in between the two. A right angle, that's your 90-degree angle. The measure of it equals 90 degrees. And a lot of times in the pictures, to show it so you know that it's 90 degrees, I'm going to put a little right angle symbol in there, the little square. The obtuse angle, that's one that's somewhere between 90 and 180. And again, cannot be 90 degrees and it cannot be 180 degrees, but anything in between would justify obtuse. And then my last one is my straight angle. And this is why I didn't want to talk about an angle as being two non-collinear rays, because here you have collinear rays. Makes an angle, call it a straight angle, and the measure of it, it's 180 degrees. Congruent angles, similar to congruent segments. Congruent segments were two segments that were equal in length. Well, congruent angles will be angles that have equal measures. Now notice when I got rid of that box, I put in these little blue arcs. The blue arcs will show us that angles are congruent. And I could go with, here I have doubles. I could have started with singles. If you get too many angles in that you want to show, we can go to 3 arcs, 4 arcs, etc., etc. And then down here is just my little statement that says that the two angles are congruent, angle M being congruent to angle N. I'll get to that later. I want to finish up with our vocab. Here's angle bisector. And again, I go back to things that we already know. We've talked about a segment bisector. Well, that was anything that cut a segment into two congruent pieces. Well, an angle bisector is very similar. In this case, it's going to be a ray, or it could be a line that would divide an angle into two congruent angles. So in my picture, the green ray is the angle bisector because it took my black angle, cut it into two congruent angles, and I know that because I see the little congruent arc symbols on both sides. And I believe, yes, that's going to conclude all of the notes part. I will also have a video on the two examples that we had in this problem, or in this